All right, today we're going to be talking about domain and range. So stick with me on this one, people. We're going to spend a couple days on this. The domain represents the replacement set for the independent variable. Ooh, there we go. The independent variable, it's usually the x values. Okay, so you're trying to answer, how can I describe all of the x values in a single statement? Okay, without listing every single x value in the function. The range represents the replacement set for the dependent variable. Okay, so that would be the y values. So you're trying to figure out how you can describe all of the y values in a single statement. The notation for domain and range is going to look like this. The domain is going to be a capital D with a colon, and then whatever you say that it is after that, and then the range is going to be a capital R with a colon. And then however you describe it after that, could be all real numbers, could be an inequality. You could be explaining what x cannot be equal to. It just depends. Now, the parent functions. A parent function is a function that has no shifts, stretches, or reflections. Okay, so if I give you this function, and I asked you, what's the parent function? If I take away all of the numbers except for one, my parent function is going to be just x squared. Okay, I take away all the shifts. Another example would be if I give you, let's do an absolute value function. The parent function of that would be just straight up absolute value of x. So I'm going to give you eight functions, and I'm going to tell you the domain and range for each one and what the rules are. So you're probably going to want to write notes when you're listening to this video so you have all of these functions written down, all 8. Okay, so first off, a linear function. A linear function, the parent function for a linear function would just be y equals x, right? So because a linear function goes on forever in both directions, the graph of a linear function looks like that. The domain is going to be all real numbers for x and all real numbers for y. In other words, if I go in both directions of the line, I would go to infinity and negative infinity. So I would cover every number on the number line for the ordered pairs. Okay, the symbol for all real numbers is a double-lined R. So you make 2 lines and then you draw an R, and that stands for all real numbers. Then you don't have to write out the word all reals. Okay, a quadratic function. We already know that a quadratic is a parabola, right? The parent function is y equals x squared. The domain for a parabola is all real numbers. The range depends on the vertex. So you're going to be saying the range is like y greater than, like if the vertex is at 0, y greater than or equal to 0. If it's shifted down, like say the parabola is down here at, we'll say that that's -5, then you do the range as y greater than or equal to -5. Excuse me. Cubic function. Y equals x cubed. Looks like this. For the cubic function, it's just like the line. And any odd-powered function, the domain and range is all reals. By odd-powered, can you see? A line is to the first power, and a cubic function is to the third power. They're both odd numbers. So any odd-powered function is going to be all reals for domain and range. Absolute value. The absolute value function is a V. It pairs up with the parabola. it's going to have the same pattern for domain and range as a parabola does. All reals, always for the domain. The range depends on the vertex. So you're going to have an inequality, y greater than or equal to some number or y less than or equal to some number. Square root function. Square root function looks like that. It's half of a sideways parabola. The domain and range are going to depend on the starting point, wherever it starts. And I'm going to write that up here. The starting. And I'll show you some examples, but you're going to have x is greater than or equal to some value and y is greater than or equal to some value, depending on where the square root starts. So like you could have a square root that looks like this. And say the starting point is 3, -2. My domain would be x values less than or equal to 3 because you can see that it's going to the left. My range would be y values less than or equal to -2 because it's going down. All right, hyperbola. That has 2 branches. The equation looks like this. This is going to have a restricted domain. In other words, you're going to say what x cannot be equal to, because you can't have 0 in the denominator. So if it's the parent function, x couldn't be equal to 0. The range will also be what y cannot be equal to. Okay, and y will not be equal to whatever the vertical shift is. And the vertical shift is whatever number's added on to the function. Okay, so for example, if I give you y equals 1 over x plus 5 plus 7, my domain is going to be x can't be -5 because that gives me 0 in the denominator. My range would be y won't be 7 because that's the vertical shift. Okay, so it's going to be important that you have all of these rules. So if you haven't been writing these down, you're going to want to go back to the beginning of the video and write them down. Next one, inverse square. Inverse square is similar to a hyperbola, but it has 2 branches, but they're next to one another. The equation looks like this. Not 1 over x, but 1 over x squared. The domain is again going to be what x cannot be equal to. The range is going to be either y is less than some number or y is greater than some number, and that number is going to be the vertical shift, just like in the hyperbola. Okay, and lastly, sine and cosine function. When you go to graph them, you need to have your calculator in radian mode. They're circular functions. Looks like this. The domain for both of them is all real numbers. The range depends on the maximum and the minimum. Okay, so you're going to be having a double inequality. However low it goes to however high it goes, wherever the peaks and the valleys, the highs and the low points are. All right, let's look at an example. So this is going to be on the assignment. You're going to be given a function and asked to sketch the graph. So this is a parabola, and the graph is shifted up too. So it's going to look like this. Every parabola has a domain of all real numbers. That's one of the rules. All reals for every parabola for the domain. The range, can you see that this shift moved everything up to 2? So my lowest y coordinate is 2. So it's going to be y greater than or equal to 2 for my range. Remember, you're trying to describe all the x's and all the y's in short statements. Here I have a hyperbola. You can see that just from the equation that x can't be 5, because if it was, I'd have 0 in the denominator. So that means that that's going to create this vertical asymptote here for the graph. The graph is going to look like this. And you should be graphing all these. You have to sketch the graph in the assignment. The range then is going to be y cannot be equal to, well, whatever number's added on, well, nothing's added on, so it's going to be 0. We'll do one more. Square root of x minus 2 plus 4. So the domain and the range for a square root depend on the starting point of the graph. The starting point for this graph is right here, and it looks like this. So it's 2, 4. So can you see that the x values are all greater than or equal to 2? Every point on this graph is to the right of 2. Y is greater than or equal to 4 because it's arching up. So it's y greater than or equal to 4. So you sketch the graphs, and then you state what the domain and range are for each one. You need to have all these rules written down in order to do the assignment. So hopefully you did that. So the assignment is going to be a worksheet that's uploaded to Google Classroom. You sketch the graph, state the domain and range for each graph, use your graphing calculator to graph, and then upload your graphs to Google Classroom. This was a long video. Sorry about that, folks. What is the puzzle? Somewhere over the rainbow, there is a pot of gold, maybe.